that we've had before. You guys might remember the Steph Curry problem. All right, so here, people like to raise money, you know, depending on what organization we're talking about, but one famous way of raising money is by selling raffle tickets. And so in this case, one raffle ticket's a little more than the other, right? So the type A raffle ticket only costs $2, whereas the type B raffle ticket costs $5. And so there's going to be two different prizes when they draw randomly a ticket out of the big A bucket, and when they draw randomly a ticket out of the B big bucket of all the tickets. Okay, so these are two separate drawings. One just costs more than the other. Okay, so the first thing, what is the expression that represents the total money? Okay, I'm going to leave this volunteer. So if anybody wants to volunteer what they think for number one, raise your hand. Anybody think they feel comfortable? What is the expression that represents the total money? So you got the 2, the 5, the A, and the B. I'm just going to leave this open. Anybody think they have an idea? What would the expression that equals the total money? You got a 2, a 5, an A, and a B. Okay. So we're representing this process, right? We're going to combine the money we made from selling the A tickets to the money we made from selling the B tickets. All right. So the A tickets were $2 each. So 2 times the number of A tickets is how much money we raised. I'm using the variable to represent how many A tickets got sold. So the money we raised from the A tickets, we're going to add to the money we raised from the B tickets. Okay, and then the B tickets are $5 each. So 5 times the number of B tickets, which I'll use a variable to represent. So this is the expression that equals the total money. It doesn't equal a number just yet, so we don't call it an equation. But whatever money we raise is going to equal this expression. Okay, so maybe the word expression confused you, right? It's a word you're maybe not familiar with in the sense of mathematics. You put an expression equal to something to create an equation. Okay, so now we got this second question. So what was this expression going to equal? Based upon number 2, I'm going to call randomly on somebody. Based upon number 2, what would this expression equal? Alex, based upon number 2, what would this expression equal? All right, I think Alex is trying to answer, but the audio is not working. As you guys know, you would just have to work with it. Okay. Okay, Joshua, based upon number 2, what would this expression equal? Okay, so what, Joshua, look at number 2. There's only one number. Correct, Jaden. Joshua, what's the number you see in number 2? He's responding in the chat, which is okay. There you go. Okay, I mean, that's okay. We've got to work with what we got, right? No problem. Okay, you are participating. So the total amount that we would raise by combining the money from A tickets to the money from B tickets equals 30 according to that problem. Okay, so now we're going to solve for one of these variables. And you might remember how we did this when we looked at this a couple times. Okay. All right, Alina, should we solve for A or B? What would you solve for, A or B? Alina? Alina, we're going to solve for A or B? Okay, Kian, are we going to solve for A or B? Kian, are we going to solve for A or B? All right, so basically just pick a letter. It'll be okay. Tome, are we going to solve for A or B?
B.
Okay, let's solve for B then. All right, so if we want to solve for B, we're going to leave the 5B where it is. We'll go ahead and subtract 2A from both sides. Okay, then we'll have the 5B equals 30 minus 2A. Okay, now we want to solve for B, so we got one more step. We're going to divide by the 5. Okay, now notice we get a whole number because 30 divided by 5 is 6, and that's what we want. If this became a fraction that was not simplifiable, this would be harder, what we're trying to do. Okay, what we want to do is we want to decide what the solutions are. Well, we're talking about A and B, which represent the number of tickets. We can't have negative numbers for tickets. And if you're selling tickets, you can't sell 2.67 tickets. So the only solutions we're interested in, what combinations of 2s and 5s would equal 30? The only ones that work are going to be whole numbers. And when we say whole numbers, we include 0. Right? Whole like a whole, 0 is included. Okay. Look at the denominator. If you remember, we're going to use the denominator to help us. Okay, so looking at that denominator in what's multiplied to the A variable here. Yasmin, what's the denominator here?
5.
So we're going to use multiples of 5. And the first multiple is always 0. 0 is a multiple of every number because 0 times anything is always 0. Okay, so when we put 0 in here for A, if we put 0 in here for A, Brandon, what are we going to get if we put 0 in here for A? What's B going to equal if A is 0? Brandon? Okay. So Jaden, when we replace A with 0, what's B going to equal? Correct. Again, the audio issues, so 6. Because 0 times 2/5 is 0, 6 minus 0. Okay, so then we get B, 6. Okay, now what's the next multiple of 5? 5. Okay, and then notice what happens when we replace the A with 5. Put a 1 under that, we can simplify. We get 6 minus 2, which is 4. Now we can use the rate of change. Now maybe you're someone who can do that at this step, but if you get the second multiple of 5 and use it to find the B, you'll see the pattern. And it looks like we're adding 5 as we go down to get the A's and subtracting 2 as we go down to get the B's. So 10, 2, 15, 0. And now we're done. We got all the possible solutions of whole numbers based upon 2s and 5s that combine to be 30. Okay, and again, you might remember the Steph Curry problem, all the ways we could combine 2s and 3s to get 30 points. It's the same type of problem. So this is helpful. There's no need to guess and check, and it can quickly be done, and you know it's accurate. That's very good. Okay, so I think now is a good time for a break. So I'm gonna go ahead and we're gonna have 5-minute break, and we're gonna come back and we're gonna look at one thing today. Okay? All right, so 5-minute break starting now.